how do we calculate the pH of a basic solution? Well, what we do is we calculate the pOH, not the poo. That's what it says in the book. So we call it pOH. And sometimes this trips students up. So in just the same way as the pH is the negative log of the concentration of the hydronium ions, the pOH is the negative log of the hydroxide ions. Okay, so we can just, depending on what we're doing, we can just use these relationships, remembering that it's identical to pH. And then we can, because we know that 14 is the, well, because of the constant for the separation of water, if we have equal numbers of hydronium ions and hydroxide ions, we end up with a value of 14. That sets our upper limit for pHs at 14. We can't have a number higher than that. We can actually end up with acids that are lower than 0, but that puts that caps us at 14. And so we can then say that if we calculate the pOH, we can find the pH by subtracting that number from 14. Now, the examples on page 45 are actually example calculations for pH. So if we flip over to the sample calculation, which is example number 4, it says calculate the pH of a 0.2 molar solution of calcium hydroxide. Well, we know then that the concentration of the hydroxide ion is 0.2 moles per litre. And we know that the pOH is equal to the negative log of the concentration. So that's going to be the negative log of 0.2. 0.699. So that's the pOH. Now we haven't found the pH yet until we subtract this value from 14. And that's going to give us 13.3. Okay, does that make sense?
Well, what if the pOH is negative though? Because there's nothing to stop you getting that negative.
You can't sort of have a negative concentration. If you had a negative concentration, then I guess that's indicating that the H plus ions are in excess rather than the OH ions. This has to be a positive value here. I'm not quite sure what you mean there.
You can have a negative pH, like you said.
All right. We can only have a pH less than 0 of an acid.
Oh, okay.
Yeah. So remember that at pH 7, the concentration of acid ions and base ions are equal. So there's no excess of H plus ions or OH ions. There's equal numbers. Then if we have a lower than that, a pH lower than 7, we have an excess of hydronium ions. And the place where you can end up with values less than 0 would be in like mine tailings, very, very nasty environments. That's where we would see very low pHs. But by and large, our pHs are 0 to 14. Okay, so that's what we're used to, isn't it? That we'd say anything that's less than 7 is an acid, and anything greater than 7 must be a base. Okay? but we've pretty well locked in the upper limit to 14. It's just that it is possible under certain conditions to end up with pH less than 0.
So it's just that you can't have a concentration of like 10 moles per litre of that basically?
Well, after a while you add so much,
Yeah.
and then it won't dissolve it.
Okay.
So there's the limit of solubility. And for those ions to be available, you need to have
Okay.
water.
So it's just that the hydroxide ions are less soluble typically than the hydrogen ions? Because
Solubility, 10 molar is it's a very high concentration.
okay.
I might just turn off the
Camera.
video.
Yeah.
And how about you can